Okay, so yesterday we did determinants. Why did we do determinants yesterday? So we can do inverses today. Why are we doing inverses today? So we're gonna use it to solve tomorrow. Okay? When we solve, even today, there's gonna be multiplying is coming back. Okay, so you have to remember how to multiply matrices. We'll have to do inverses tomorrow, multiplying. We're gonna do scalars today, right? So all of our math stuff is gonna come together today and tomorrow. We're gonna have to solve for variables tomorrow, okay? So lots of pieces put together. So you're not allowed to forget. Okay, thanks. When we are doing inverses, there's a couple of things we need to know. We need to know what the notation of inverse is. Is that little -1 exponent? It looks like an inverse. And then we have the identity matrix. Okay, your identity matrix has your ones going down your diagonal. Where's my pen? Y'all see my what? Found it? No. Okay. Do y'all see my tablet pen? I don't know what it looks like. Black. No. Pen to it on the tablet. Is it under your chair? All right, so our identity matrix has the ones going down the diagonal. The identity of a 3x3 matrix, okay, it's the same thing. Ones go across the diagonal. Everything else is filled with a 0, okay? So this would be the identity matrix of a 3x3, okay? So that can happen also. To be able to tell if two matrices are inverses, of each other, you multiply them together to see if you get the identity matrix. That's like getting 1, okay? Because let's think of inverses. What's 2 divided by 2? 1. That's kind of the inverse thing, right? Like if we have 2x, you're trying to get rid of the 2, you divide by 2, you do the inverse. So to do the inverse of something, you get 1 as a result. For them to be inverses, so A times B has to be the identity, and B times A, has to also be the identity. They have to both work out. Remember we saw A times B does not always equal B times A. Remember doing those? Okay? So we do have to do it both ways. If you do A times B and you get identity, awesome, you're not done. You have to also do B times A and make sure you get it again. Okay? Because you might not. And if you don't, then they're not inverses. All right? So it has to work for both. So let's practice. So right here, number 1, we have A and B. I want to know, are they inverses of each other? So we need to multiply A times B together first. And then and if it's identity, then we'll do it again for B times A and see if we get it again. So multiply them together. Yep. It's 2x2s though. I told you this is all going to have to, you're going to have to keep using it. There we go. So 1, 2, 3, and 4 will get multiplied with -2, 1, 3/2, and -1/2. All right, so to remember how to multiply, it is first row, first column, right? So when we do that, think about it. What is 1 times -2? All right, what is 2 times 3 halves? It's 3. What's 2 times 3? 6. 6 divided by 2? 3. There you go. All right, so then we do it again. But now we're going to go across. So we have my first row, but now we're going to do second column over here. All right, so what's 1 times 1? 1. 2 times -1/2? -1. Yep, good. All right, now we're going to go across our bottom. So 3, 4 times my first row of -2 and 3 halves. So what is 3 times -2? What is 4 times 3/2? Positive 6, yeah. 4 times 3 is 12. Divided by 2 is 6. Good. All right, last one. We do second row, second column. So 3 times 1 is 3. 4 times negative 1/2 is negative 2. All right, so how do these simplify? What is negative 2 plus 3? 1. What's 1 minus 1? Negative 6 plus 6? 3 minus 2. What did we just get? Not yet. What is this called specifically? This is the identity matrix. So far, we could say yes, but we're not going to say yes. Because we have to do B times A. Yes, you do. It has to work for both. It can't just work for one. It has to work for both. Okay? So now we have to do B times A. So we have negative 2, 1, 3 halves, and negative 1/2. We're going to multiply that with 1, 2, 3, and 4. All right? Multiply these together. Look at that. Negative 2 plus 3. Right? That's already a 1. So far, we're on the right track. Next, we do negative 4 plus 4, which gives me 0. My second row, we have 3 over 2 minus 3 over 2, which gives me 0. And then, what is this? That will be 3 minus 2, which gives me a 1. Yes. So did we get it again? Yes. So are these inverses? 3 over 2 times 1 is 3 over 2, right? Negative 1/2 times 3 is negative 3 over 2. So yes, they worked. Yay! All right. So before you do number 2, freeze. Freeze before you do number 2. I know you are. Some of you do AB. Some of you do BA. Spread the love. See if it works. Ready, set, go.
That's not funny. I literally know it's
You should already be done.
I guess.
Yes. Why is that all I had to do? How can I already say no?
Oh, because it's not.
The very first entry that any of you did, whether you did A, B, or BA, the very first number you get, nobody got a 1. Right? So right away, you know these are not inverses of each other. It has to, yeah. So AB, your very first entry is what, a 0? Well, that's not part of my identity matrix, so I can go ahead and say no, they're not inverses. If you were doing BA first, you got 14. Well, that's not the number 1, so go ahead and say no. All right? So sometimes these are short and easy because you can already tell it's not going to be the identity matrix. Okay? So for these, you could go ahead and stop and say, no, they are not inverses. All right? So don't make it harder than what it's going to be. Questions on how to determine if two matrices are inverses of each other. Because now we're going to actually find the inverse of a matrix. We are going to find inverses of 2 by 2 matrices today. We will not do it with 3 by 3s. Is it possible? Yes. Are we going to do it? No. All right. We're going to stick with 2 by 2s. So, what is step 1 in finding an inverse? Find the determinant. Remember that thing we did yesterday? Yes. And since we are doing 2 by 2s only, how do you find the determinant of a 2 by 2? The AD minus BC. Remember those diagonals yesterday? This minus this. Yeah? Okay. So you have to find the determinant. That becomes your scalar. Are y'all listening? There's a lot of talking going on when I'm talking. Okay? Your determinant becomes your scalar. Okay? Your original matrix. Step 1 is to flip your left diagonal. So AD, they get to switch places with each other. Okay? They switch spots. B and C, they stay where they are, but what happens? There's a negative attached to them now. Okay? If they were already a negative, what do you think happens? It would become a positive. Okay? So A and D switch spots. B and C stay where they are, but their signs are going to change. Okay? Then you multiply 1 over your determinant to everything as a scalar, and then you get an inverse matrix. Okay? I know, today it seems random, but we're going to use it tomorrow. Okay? So let's do 1. Here we go. We have matrix A for number 3. It's asking me, does the matrix have an inverse? How could it not have an inverse? Why would it matter if the determinant is 0? Yeah, you can't divide by a 0, right? If that's part of my determinant, 1 over 0, not a thing, right? Remember, fractions are parts over wholes. I can't have a cake if there is no cake, right? So we can't divide by 0. All right, so let's determine first if a determinant exists. Remember, we do 4 times 2, which is what? Which is 8, and we're going to subtract from there 3 times 2, which is 6. We did this yesterday. 4 times 2 is 8, minus 3 times 2, which is 6. So if 2 is my determinant, do I have an inverse? Yes, so we're going to keep going. Okay. If it's 0, you say there is no inverse. Okay. Correct. Yep, it could even be negative 2. Yeah, negatives would work also. So our scalar is going to be 1/2. Okay. We have to multiply it to our flip-de-do matrix. Okay. Which means A and D switch spots. So now it's 2 to be first and 4 is last. B and C stay where they are, but they're each going to get their sign changed. So they become negative 2 and negative 3. All right, so when I multiply this through, what is 1/2 of 2? 1. What's 1/2 of negative 2? What's 1/2 of negative 3? Negative 1.5, or negative 3 over 2, same thing. And what's 1/2 of 4? 2. And that is our inverse, right there. Okay, so we get another matrix, and we will use this tomorrow. It will be very, very important to solving our systems tomorrow. Yes?
What's the A negative 1 mean?
That's the inverse. So at the very beginning of the notes, we talked about that's the notation of it. That's how you notate inverse. It looks like an exponent of negative 1, but it isn't. Okay? That is our inverse.
So basically first just find out, make sure the determinant's not 0, and then just go from there.
Yep. All right, so number 4. Let's figure out our determinant first. How do I set up my determinant for this one? Negative 20 minus negative 20. Uh-oh. What does that mean?
What you not do, no solution.
There is no inverse to this one. There is no inverse matrix to number 4 because we got a determinant of 0. That can't happen.
I like those problems.
That's your favorite one? I think you'll like the next one too, though.
If it's no inverse, then yeah. If it's not, no.
Oh, I like the next one.
I see. I told you would. I want you to do number 5.
Oh.
I want you to do number 5. So what is the inverse of matrix C? Why did you like number 5 so much?
It was easy.
Why?
You just multiplied everything.
Yeah, because my determinant was 1. Did you all get the determinant is 1?
Yeah.
So when you have a scalar of 1, that's nice because your inverse is just your flippy-do matrix. So you switch A and D, change your signs of B and C. We get 3, -4, -5, and 7.
You have to put the C -1.
That's how you show inverse. Guys, listen. She had a good question. If I just said C equals all of this, that's wrong. C does not equal this. C equals 7, 4, 5, 3, right? C inverse. That -1 is important. That shows inverse. C inverse equals 3, -4, -5, 7. All right? You do number 6. All right, today, what'd you get?
Oh, I got 8, -6. Am I already wrong?
It's 1/2.
Oh, because you're supposed to put it over.
Yeah. It's okay. It happens. What's the first one, Adam? 2. Ethan, what's my next one?
I am right.
Yep, -3/2. Jimmy, what's the next one? Taylor, what's the next one? One. Good. How do we do, guys? Did you do wonderfully? Huh? -3/2 is -1.5. So one of those. Yes. That is the same thing. -1.5 is -3/2. Questions for me? All right, when you work on your classwork, okay, you have 7 problems tonight. You're doing 7, 9, and 11 first. I want to know, are they inverses? So what do you have to do? Multiply them together. A times B and B times A. What do you want to get as a result when you do that?
0, 0, 1.
The identity matrix. Good. 29, 31, 33, and 35. I want to know, does it have an inverse? How do you figure out if it even has one? Your determinant cannot be 0. Good. And then I want to know what the inverse matrix actually is. Separate piece of paper, because you will be turning it in, and I don't want your notes.